Welcome to GermiNation, the podcast where seeds tell their stories. I'm your host, Cindy Hicks, coming to you from the Iowa State University Seed Science Center, a global leader in seed research, education, and outreach. Each episode, we dig into the beauty, wonder, and science of seeds, those tiny little powerhouses at the heart of agriculture, biodiversity, and global food security. Through conversations with scientists, farmers, industry leaders, and change makers around the world, we explore how seeds connect us, sustain us, and shape our future. This is GermiNation, where every great story starts with a seed.
Hey, little seed. What do you need to help you grow?
Fertilizer is essential to modern crop production, but its rising and unpredictable cost continues to put pressure on farmers around the world. The expense can influence planting decisions, seed demand, and the crop traits breeders prioritize. Fertilizer also carries an environmental cost to groundwater quality, greenhouse gas emissions, and the significant energy used to produce it. So it would stand to reason that improving how efficiently crops use nitrogen could benefit farmers while helping agriculture reduce nutrient loss and its environmental footprint. The answer may be in plant genetics, helping farmers produce strong yields while applying less fertilizer. Today we are exploring promising research involving flax, an important oilseed crop valued for its nutritional benefits and beautiful blue flowers. Canadian and Chilean scientists have identified more than 1,000 genes involved in how flax responds to nitrogen stress. Their findings could help plant breeders develop varieties with stronger, more adaptable root systems that use the nitrogen already available in the soil more efficiently. Science that can transfer to other nitrogen-loving crops like corn and rice. Joining us today is Dr. Bourlaye Fofana, a research scientist with the Agriculture and Agri-Food Canada at the Charlottetown Research and Development Center. He's here to discuss how nitrogen-efficient flax could lower production costs, reduce nutrient runoff and greenhouse gas emissions, and provide a research model that could potentially benefit other crops.
Good morning, Dr. Bourlaye Fofana. Thank you for joining us this morning all the way from the east coast of Canada to talk about your exciting research. To begin, could you describe the challenge you and your research partners were trying to address and why improving nitrogen use efficiency in flax is important?
Thank you very much, Cynthia. Flax is an important crop that has been used since humanity has started doing agriculture. It is a plant which doesn't have a strong root system. It has a shallow root system. And the plant itself, for not only flax, but all plant needs their roots to get nutrients from the soil and to be vigorous and be productive. So the challenge we are looking at was how flax can have a stronger root system and how they can get efficiently nutrient from the soil. And we have in Canada a large collection of flax, and we have been studying that for different aspects. So what we did over here, we'll look at a diverse panel of flax germplasm to see which one may have some differential in root system. And then we grow them to see which one may be using and striving better on low nitrogen context. So with diverse collection we have, plants we had, we evaluate them in two systems, good low nitrogen and high nitrogen. So those who were striving better under a low nitrogen context, we look at them further. So, that was the challenge. So, because the challenge that are associated to that mostly is the fact that growers have to invest a lot in fertilizers. And nitrogen is a main component of any fertilizer you are using. And the cost associated to a fertilizer in terms of monetary but environmental issues are also high. So, which we want to address is both plant nutrition, economic, but also environmental aspect.
You've compared a plant's root system in the past to its nervous system. How do larger or more adaptable root systems help flax locate and use nitrogen already available in the soil?
Yes, we can compare root system as a nervous system because the interaction that the plant has with soil is coming from a root. And based on the network, the root system will be the volume, but also the size in terms of length, but also in terms of width, determine how they will be interacting with water in the soil, through which they are getting all of the nutrient. So, and if you are looking at the diversity of collection that have different kind of nervous system, you compare, for example, people whose we all have a brain, but the quality of a neuronal connection in our brain determines our capacity to get things quicker compared to others. So the same thing in plant. The more the root system is large, deep, the more competitive they will be compared to those who have a very small root system. This is why we can compare, make the comparison.
Well, your research identified more than 1,000 genes that respond to nitrogen stress. How did you identify these genes, and what did you learn about the plant's response?
You know, plants in general contain more than 40,000 genes, depending of cross species. So, but narrowing down to 1,000 is quite significant. And the way we do that, there are different aspects to do that. We call a technique called transcriptomic. We take the transcribed section of genetic material from an organism. We sequence them and we analyze them in a certain context because the gene that exists in the plant, they all are activated under some circumstances. If they are dropped, they may be activated under a drop condition. If there are deficiency in nitrogen, they may be activated. If there is too much rain, flooding, they may be in different contexts. So, depending on the context you are growing your plant, the gene may be responding differently. So the way we did that, we grow our plants in the different contexts, the nitrogen context, and genes which were responding to low nitrogen context, we try to identify them through the expression, but also, as I mentioned that to you before, we had a panel of germplasm. So we did another morphological trait association. For example, plant will have more biomass, more root depth. We look at 21 traits in the soil population, and we make some association between these trait characters with the genetic makeup in the plant. So coming with a precise location at which these traits are associated in the genetic makeup of a plant. So following that, we knew that the region in the genome where these traits are associated with, what are the genes which are in that neighborhood? And then we compare the gene with the one we look at the gene expression level. So that's coming us to narrow down from 40,000 to 1,000, and among the 1,000, those are more specific to nitrogen metabolism.
How long did this take you to do?
the research can take some kind of, because you have to sequence your plant first to have how the gene structure are in the genome, and then you transcribe them. You take some nucleic acid material, sequence them, and compare the outcome of all of the approach, not growing that in the greenhouse first to have a fertility trait, but also a genomic aspect, and combine all of the data and analyze them to come to that. It can take about at least 1 to 2 years, at least.
So when it comes down to it, this is something that plant breeders could use. How would they go about using this genetic information to develop flax varieties that maintain strong yields, but do so with less fertilizer?
So what is interesting in the study is that not only we locate the region of a genome that are impacting the nutrient efficiency use, nitrogen efficiency use. So we know that what are the segment, and we are able to look at the markers that are linked to it. And these markers are the guidance for the breeders to see, okay, what we are using in our breeding program, we can use that marker to see whenever it's present. We can do that our crossing and select the progenies that may be nitrogen efficient users. So to answer the question right away, to a marker we have identified here that are useful for breeders.
On the other side, you have farmers. Could these nitrogen efficient varieties reduce fertilizer costs for farmers without sacrificing yield or seed quality or the nutritional characteristics that flax is known for?
Definitely, because if you get a flax plant that is using less nitrogen but producing enough biomass, not only in terms of shoot, leaves, and the yield is associated with biomass produced by the plant, the leaves, which are capturing the light to translate that in carbohydrate, going to the seed. So if you can have a flower variety striving under less use, I'm not saying zero, less use, okay, less use in nitrogen, and producing enough biomass, the biomass will be translated to yields at the end of the day. And the cost associated to nitrogen fertilizer by growers is quite high. I would say all fertilizers, because they are coming together. And fertilizer, nitrogen is mixed with other nutrients like potassium, phosphorus, and so on, to have a combined fertilizer for plant. But in that, we know the pollution associated to nitrogen is not in terms of green gas emission can be high. So if you are trying to reduce the amount of nitrogen in our use of fertilizer, not only the cost will go down, but also in terms of environmental impact will go down as well.
Well, and with the ballooning cost of fertilizers hurting farmers, I can see how this would definitely be a benefit. But beyond the economic benefits, you mentioned greenhouse gas emissions. How could these crops that use nitrogen more efficiently help reduce greenhouse gas emissions, nutrient runoff, and agriculture's overall environmental footprint?
Yes, definitely. So nitrogen runoff, if a plant is able to use efficiently the amount of fertilizer that is provided, nitrogen provided to them, a grower doesn't need to put more in the environment. So, and the risk of leaching to go in the environment will be reduced. So the less we use and the more efficient they are used by the plant, the better it is. Environmentally will be good, but also growers will be spending less in terms of spending more money to buy in more nitrogen fertilizer, for example.
When I first read about your study, the first thing that came to mind, of course, I am in Iowa, and in Iowa, corn is king. But that comes with a price. And so, even though this study focused on flax, could the methods or genetic insights from this research be applied to other crops?
Definitely. So what we did here, I will not say that it's rocket science, right? So because the technique we are using can be applied to any other crop, but you have to adapt. Because the marker you found in flax, you will not see exactly the same marker in corn, for example. You have to look at on the genome of a corn to locate the gene that may be responsible for it. It may be the same gene family, but not exactly the same segment of the DNA that will be used directly from flax to translate it to corn. That doesn't work that way. So a researcher working on corn have to do the same kind of work on corn to identify the genetic makeup which is linked to less use of nitrogen in corn. But definitely the approach can be applicable across crops.
That's very exciting news, especially here in the Midwest, where we often have controversy over the use of nitrogen fertilizers. You know, farmers need them. They have to make a living, and we need the food that comes from them. But then on the flip side, you have the nitrogen in the water source and such, and really a hard thing for us here in the Midwest. What could that broader opportunity mean for plant breeding and the global seed industry?
So what I can say here is that more research has to be done for all of your crops. We know that when a plant is getting nitrogen as a nutrient, it's not only for the growth, it's also for the quality of the seed from which it's coming, because in protein you have nitrogen, right? So those are contributing to the quality of the seed you are getting. So you will never get a net zero fertilizer without nitrogen. That will not only the quality will get impacted, but when you are getting a plant that can be using less, contribute to a higher biomass, yields, but also quality, we have to go in that direction in a such way that we can minimize our use of natural fertilizer to have, but this means that selection of some varieties that are really efficient use of that. The term efficient is very critical here, because doesn't mean that because if you are giving less and they are using the less, all of the less that are provided, this is efficiency. But it doesn't mean that you have to provide more and the rest is getting wasted. So efficiency, term efficiency is quite critical in all of these principles I'm describing here.
And as I've been talking to you, it's made me wonder, how far away are we from seeing crops develop, such as the flaxseed, and in the hands of farmers where they can be of the most use?
Yeah, so the research we are doing are really a bit far from the farmer directly. Usually it's breeders who are developing varieties to put that in the hands of seed companies, and seed company will be selling that to farmers. We are not at this stage. So we are developing concept and method that will be useful for breeders to develop stronger and better varieties that could end up one day in the hand of farmers. So, and our research usually is a bit far, as I said, not only in terms of techniques, but also in time, because breeders, when they get these markers, it takes them other time frame for them to develop a variety, select them, because selection is not only based on nutrition, nitrogen efficient use, but also you have to have what are the size of a seed, the quality or disease, all of this kind of thing, to be integrated before coming to a super variety, combining all of these things. So it's not such straightforward approach for either us, but also for breeders to be, but it's we are on the right path.
Is there anything else that you think our listeners would like to know about your research?
To me, I am passionate about flax. It little blue flowers, purple flowers. So, what I can add here in North America, especially in Canada and US, flax research is going down, and we used to organize a flax genomic workshop every year in San Diego. But the last 3 years, since the research of flax going down, we cannot organize a full workshop anymore, simply because the number of researchers work on that. So most of flax research now is somewhere else, Asia, and not France, and Eastern Europe. So to know in North America, our flax industry here, I think more research has to be done. We have to revitalize that. That's all of you can I say for now.
Dr. Fofana, thank you so much for joining us on GermiNation today.
It was my pleasure, Cynthia.
Thank you for tuning in today. We'd like to give a special thank you to Let's Roll Snowball for allowing us to use the seed song. If you enjoyed it, be sure to check out Let's Roll Snowball on YouTube for more fun and educational songs for children. GermiNation is a podcast produced by the Iowa State University Seed Science Center. The views and opinions expressed by guests are their own and do not necessarily reflect those of Iowa State University or the Seed Science Center. This podcast is intended for educational and entertainment purposes only. Thank you for listening to GermiNation, where every great story starts with a seed.